5G opens up a new way for connecting a vast number of devices together. So the more interconnected we get, the more possibilities they open. So not just AI, but self-driving cars is one way to look at it. And now you're entering space as well. So the greater communication with space objects and satellites and that stuff. So greater interconnectedness is, I think, the frontier that's moving the internet right now.
Well said. Anyone else would like to add to that point and say what future technologies will be used through the internet? Anyone?
Maybe we don't have to travel to the other side of the world for medical assistance like surgeries and all that stuff.
Yes, very good. We can have a virtual, perhaps, doctor in form of a robot.
I can hear him.
Yes, you're right. Very good. So when you think about it, there are so many other technologies that haven't actually been explored, right?
Yes.
Fine. Now let's go back to the lesson. We start with networks, how they affect our lives. Okay. As we discussed, communication is as important to us as reliance on air, water, food, and shelter. Okay. As we discussed, without communication, without the internet, we cannot imagine our life. I remember when I started in this line, Bill Gates had a quote, and he said that one day internet would be as important as water or electricity power. And he's right. Without the internet, we can see that we cannot function. And as we go along through these slides, we will see that we are coming towards a new paradigm, which is convergence. Our entertainment, our communication, everything is converged on the internet. Okay. Remember the early days when for entertainment we used to visit a shop and rent a video cassette or perhaps a video DVD or a CD or a Blu-ray. These days we don't need to do that. All we have to do is stream or download, right? The whole concept of all of us sitting at our homes and going through a lab during this pandemic rather than being in one geographical location. And in many respects, if you think about it, this feature is much better than being in an actual lab. Of course, we can talk about pros and cons, okay? But the whole concept of geographical location not being important, how is that possible? Obviously through networking, through internet, through connecting with each other. We can create global communities. Social media has changed our world for the better or for the worse. Well, that's debatable. Okay, we can create human networks. We can do research across campuses. So many things can be done. Now, let's go to network components. What are the components of a network? A computer network, ever since its beginning, it has kept changing and kept developing with the advances in hardware technology. Okay? Every computer in a network is called a host and device. And there are two kinds of computers. There can be a server or it can be a client. A server is basically just like a normal computer, but it has got much more powerful hardware devices inside it, much more powerful, perhaps a CPU, much more memory. And it can service the clients. example of some of the servers, as you can see, email server, web server, file server. For those of you who have done database systems, remember you need a database server, and as a client, you access that database server. Okay.
PTSD intensified.
What was that? Could you repeat?
PTSD.
Yes. Okay. Clients are computers that access the server and use information on that server. Okay, you can download stuff if it is a web server. You can get your email if it's an email server and so on. Okay. We also have a database server. We have got a file server. Okay. In this day and age, it's always beneficial to store data in a centralized location, and we have got large data centers that do that. And you may say that, hey, what happens if somebody bombs that data center? Don't worry about it, because that data center in one geographical location is replicated to other geographical locations. So we'll have one in New York, one in Sao Paulo, Brazil, one in Singapore, one in perhaps Hong Kong, one in Sydney. So if one location goes down, if there is a geographical disaster or natural disaster, if one location goes down, no worries. Your information is all safe and secure. All your banking information is not in one geographical location. It's replicated to all around the world. Okay? So internet has made our life much more easier. Okay?
So, sir, no harm on Curtin server this time will attack.
Can you repeat that, dear?
So there will be no harm on Curtin server if Sam tries to hack it?
Well, we're not trying to hack it, man. That doesn't make sense.
If he did, he wouldn't know.
It makes sense. If you want to hack it, it makes sense to hack a university server. You have access to sensitive information. But the thing is,
Sir, but I can't hack it.
Mr. Foad did.
I'm an ambassador to the university. I'm an ambassador to the university. Hacking it would be the worst thing I could do legally.
Actually, people hack because they want information. Remember, in this day and age, we are living in the age of information. In fact, information is key. Surpassing the industrial age and the agricultural age. Now we are in the information age. Everybody wants information, and that's how we have the reason for accessing data that doesn't belong to you, hacking. And one of the components we're going to study today is network security. And that's the very important thing which comes with networking, because people want access to things that they don't have. And every country in their right mind has got a new defense position, a new defense branch known as cyber. They want to make sure, because countries attack each other through computers, attack each other's network. And it makes sense to have a protection. And we'll be covering some of those as well. Yes, and the question you asked, yes, you can attack through the internet somebody's network. That is why we have to make sure that your router has got a strong firewall. Okay, the person accessing the device, both physically and geographically, is an authorized person. For example, you all have been to Curtin, but have you ever seen where they put all these switches and the wires that go from the plenum all the way down to the switches and other networking device? Have you ever seen the actual router? I've been working there for so long and I haven't even had access to that room. Why? Because it's very important to protect your network. And in fact, a Curtin network, a university network, is a closed network. We have our own local area network. accessing it within would be perhaps easier than accessing it without, I mean, from outside. Okay? As you go through this course, you will understand that network security is always an issue, and you will perhaps come up with solutions. Okay? Now, we have got also peer-to-peer network. Now, in client-server network, we have got a server which, as it says over here, we have got a server that gives information to the end devices, to the client. But in a peer-to-peer network, we don't have that. You can share file, you can, you can download things that do not belong to you, right? You know what I'm talking about. So you can do many things in a peer-to-peer network. I'm talking about these file sharing software that we use to download intellectual property, which is illegal. We are not supposed to do that. Okay? Rather than streaming and paying a relevant fee to the streaming companies, actually, if you're downloading that same material, you are committing an intellectual theft. Okay, no matter how much you tell yourself that it's okay, everybody does it. Actually, it's not okay. You have just stolen from somebody. Even books that you don't pay for. These are all intellectual thefts that a person who downloads engages in. Okay? The problem with peer-to-peer is that there's no centralized administration, and it doesn't have the security, and it's not able to be expanded. Okay? And performance is perhaps slow. But of course, when I give an example of downloading pirated material, it's not exactly peer-to-peer. There is a server which acts and gives the data to the requester, to the client. And why do they do that? Why do people engage in piracy? Because when you download materials from them, you get to look at advertisement. They are supported by advertisement. They get rich by stealing intellectual property because they get advertised material on their site. Okay? That's why whenever you try to download materials, there are so many ads that you have to go through. Otherwise, they can't survive. An end device is your computer, your smartphone, your IP telephone, can be even a server. Okay. Now look over here, right over here, my dear students. I have a router. If you look, I have a router here. This is a graphical representation of a router. This is a graphical representation of a switch. Okay. And this is your IP telephony. Okay. So here we have a local area network connected through the internet to another local area network. And a local area network is maintained by that enterprise itself. Okay. We also have intermediary network device. An intermediary device interconnects end devices. A very common intermediary device that connects the same network, the same hosts in the network, the same end devices is a LAN switch. The moment you connect one network to a different kind of network, you need a router. When I say different kind of network, I mean different range of IP addresses. In this unit, you have to learn how to give IP addressing. Okay? Especially IP addressing flow is a bit tricky. So you have to learn the rules and the calculations. Okay? These are some of the network media that we use. Okay? Of course, we have got wireless. which is becoming more pronounced in today's age as we go along with the new technologies given to us by IEEE. But we also have mediums, like we have the copper medium. I told you during the lecture that the UTP cables have been in use since the early days, okay? And they're still being used. In fact, right from the early 80s until now, the market has really embraced the UTP cables. In fact, they came out with a better version of it, known as STP, shielded twisted pair, as compared to UTP, which is unshielded twisted pair. The shielded one will ensure that the noise means disturbance, the noise in the medium is reduced. But the industry didn't adopt it the way they have adopted UTP cables. Until today, we use UTP cables. And the reason we have got fast internet these days, the reason we can Netflix is this fiber optic backbone that is being laid out all around the world. And of course, we have got wireless routers, and we have got wireless connection devices as well. Okay, so technology is changing for the better, definitely. Now, I would like to invite you all to perhaps participate and answer some questions. When I use the term host, what do I mean by the term host? Anyone?
The person who's trying to access.
Yes.
Or end device.
Yes. Anyone else?
The person who is giving you the network or giving you the connection. The host, right?
Yes. The host.
Person with admin rights.
Yeah.
Can be. It can also be a workstation. It can also be perhaps a server trying to access. Correct?
It can be a network provider.
Yes, that also. But over here, the reason you have to know the difference is more proceeding to our terms, because we are learning networking, so we have to use certain terms which is relevant to us. A host would be more of the workstation, the client, okay, the device that connects to the network. So there are two keywords here, network and a host. Host being the person that accesses the network. I'll tell you why you have to know these technical terms. Because when you give an IP address to a computer, there are two things that you have to know. What is the host portion of the IP address, and what is the network portion of the IP address? Okay. Well, don't worry about it now. We'll learn more about it. Another question I want to ask you is, which one do you think is better, a client-server network or a peer-to-peer network?
Client server, since in a peer-to-peer network, you can compromise security. If you get into one of them, then you can start getting into all of them. Very
good, well said. So security is an issue in peer-to-peer network, correct? But
that is correct.
Yeah. If you're at home and you have perhaps 3 computers and you want them to be connected to each other, what would you do? Wouldn't it be better to have a peer-to-peer network instead?
That is correct. I mean, if it's in a localized environment, you don't expect other people to come out or come into your network, then it's better if you keep it peer-to-peer. But in a larger network, it's better to keep it client-based, since a lot of people can mean more chances of breaking into your network. It's much difficult for a hacker to get into a 3 people peer-to-peer than a 50 people peer-to-peer.
Well said.
What do you mean when you say like connect, like share files and like share media?
Yes, share media,
yeah,
share resources.
Can't we just set up an FTP server? Like, is that also peer-to-peer or what?
No, the
Isn't
point
that
the
also a
word
network?
server, it's not peer-to-peer anymore because it's still a server. You have an FTP server that allows you to transfer files, correct?
Yeah.
So the moment you keep the word server in there, that's it. It's not peer-to-peer anymore. In a peer-to-peer network, no computer has a special identity. All of them are the same, except they can share resources. Like at home, if you want to, or even in a small office where security is not a big issue, and you want to transfer files, you might as well go for a peer-to-peer network. Network makes our life very easy. Okay. So as you say, that security is a very important issue. Now I want to ask another question. You say that you cannot give security, you cannot enforce security well in a peer-to-peer network. But can we enforce security in a client-server model?
I believe you can. In a client-server model, everyone would have their own password system and their own authentication method. You can do that. So in a peer-to-peer, not everyone is just gonna. Not everyone is going to follow it that way. But in a client-based server, everyone would be required to enforce authentication. If that makes sense.
Well said. Yes. Very good. Very, very well said. But can we say that the client server is completely secure?
I believe no network is fundamentally completely secure. So it's a lot better than peer-to-peer, but I don't think it's perfect.
Well said. So there's always a way to enhance your security. Okay. Now, let's move on to next concept, which is network representation and topologies. Okay. Now, in order to understand networking, you have to draw figures and diagrams. And these are some of the end devices that we have. Now, when I say draw and represent them, you won't be actually drawing it. You would be working with a simulation software that has got representative figures, and you have to know these figures. What a computer figure looks like, what is a printer, laptop, IP phone, a smart telephone, sorry, a smart TV, a wireless router, a LAN, what kind of media you're using, what kind of wires. All these things you have to be familiar with as far as your simulation software, Packet Tracer, is concerned. You should also know some of the terms we are going to use. In order to connect your device, I'm using the keyword device. It can be a computer, can be a smartphone, can be a washing machine, can be a refrigerator, anything with a NIC, Network Interface Card. Okay. If you look at your computer, you will have one connection known as RJ45 port. That is your Network Interface Card. Okay. That is where you connect your UTP cable. If you're using a notebook or a laptop server, you will have a wireless network interface card. Okay. Now, this is where you actually connect your wire, or even if you're using a wireless system, it will look for the wireless router, okay, and access in order to be part of the network. Now, the terms like port and interface will be used interchangeably. Okay? So this is what a topology diagrams look like. This is what you will be doing actually in your simulation software, Packet Tracer. Now, there are two things you have to remember. Two things which are very important as far as networks are concerned. A network, number one, can be in a geographical position, which is the physical position. I'll give you an example. If we were doing this lab session in the lab, SK3 lab, BTech lab, all of us would be in the lab, same lab session, correct? That would be a physical representation of us. But in this situation where all of us are together, not physically, but logically, you get what I'm trying to say?
Crystal.
Yes. So these are two aspects I'm trying to convey to you. There are two kinds of networking. Physical means the actual physical presence of the devices, computers, switches, routers. That can be one network. It can also be a logical network. It has nothing to do with the physical device. Your computer may be in Australia, but it can be part of the network. It's amazing. Okay? Or in fact, another aspect of logical topology is IP addresses. Every computer has got a logical IP address. In physical also, it has a address, but that is the hardware address that is hard-coded inside each of these network devices. Okay. If you want a machine to be part of a network, it needs two things. Number one, it needs a physical, hard-coded address, okay? Something that is coded inside every network device. And on top of that, you have to give it a logical address. And that can be IP version 4 or IP version 6. And my dear students, you have to learn both of them for this course. How do you give IP addresses and so on? Okay. So this is a difference between topology as far as physical and logical. Okay. And in today's network, you don't have to be present physically inside a location to be part of the same network. No. Logical networks can comprise different computers not dependent on geographical locations all around the world. I'll be creating for you a packet tracer simulation. So I mean, I'll be using perhaps when we come to it. Let's go. So let's look at some of the common types of networks that we have. We can have a small office, we can have a home office, we can have a medium or large, or we can have a worldwide access to network. Like some of you don't even have to be in NIRI. You can be anywhere in the world as long as you have got connection to Webex. You can attend my session and we can work together in the lab. Okay, so the size of it is different. Okay. We have local area networks. We have got wide area networks which encompass different cities and different countries. Okay. As you can see over there, for example, to go through the one, you can go through huge networks. You can go through different networks. It can be a cloud. What is a cloud? A cloud is actually a place where all the data is stored, sort of a data center. Or it can be a combination of multiple servers and so on. You can also have a LAN which is interconnected A LAN is a network infrastructure that spans a small geographical area. WAN is multiple LANs connected through perhaps a high-speed cable, or if you are connecting it from one country to another country, then you have to go through the ISP and so on. Okay. Now, having all these networks connected to each other is what makes internet possible. Okay, it's a worldwide collection of interconnected LANs and WANs. And imagine if you had to live without internet, especially your generation. Just imagine you wake up in the morning and you have no internet access. You know, it's very difficult to continue working or entertaining yourself without that, or even communicating. Okay. Some of the medium that we use in LAN, the copper wires, fiber optic cables, and wireless transmissions. Okay. The benefit of internet is paramount. But remember, although the technology was first proposed by the DARPA, American DARPA, US DARPA, when they created ARPANET, no country actually owns the internet. It's like the Wild Wild West. Nobody controls it. It's having, you know, it's continuously expanding, and it doesn't. A few years ago, they tried to control it, but then many universities said that please don't do that. That is the whole idea of having internet is having no centralized control. Okay? If they would have had a centralized control, then you wouldn't be able to download stuff like the way you're doing it right now. Okay? But we have certain bodies that maintain and give us some structure to the internet, and these are Internet Engineering Task Force, Internet Corporation for Assigned Names and Numbers, and you also have Internet Architecture Board. Okay? Having said that, the whole idea of internet being very attractive concept all around the world is because there is no centralized controller of the internet. Now, a country can actually filter contents, okay, and ensure that certain things its people cannot access. They can do that because they are the internet service provider. But many countries, you know, they don't do that because they have to go through certain policies and protocols if they want to do that.
Sir,
yes.
If I may ask, what's the difference between the internet provider and these three bodies that we have here?
Yes, very good question. The internet provider is your actual, mostly a government representative or a private body, depends on which country you are in. What they do is they give you access to the internet. You give them some fees at the end of the month or something like that. Okay, you have this permission to access their network, and their network, your ISP is connected to the actual World Wide Web, to the internet. But these different task forces, they are private enterprises that they try to improve the internet to some extent. Okay, the addressing systems, or how to make internet faster, how to ensure that we have more broadband cables or fiber optic cables and so on. Of course, these task forces, they make the internet much better, but they don't have actual controlling authority. You understand what I'm saying? But the ISP has got the controlling, the ISP of the country, yes.
So one thing, so if let's suppose I'm using the internet of Maxis, so Maxis is my internet provider, right?
Yes.
So can Maxis can Maxis access my laptop?
Yes, they can. Maxis can access your laptop as far as your browser is concerned or anything else you have shared.
If I've not shared, so if I've not shared anything, so still they can access or not?
No, they cannot access. But if they ask you to download a software, and they tell you that this software will make your internet faster, and then you download that software. But actually, that software does not do that. That software records your keystroke. That software records which websites you go to. That software records what you are doing on your computer, keeps recording what you're doing, and updates it to a server someplace.
So the accessing totally depend on the permission from my laptop, right?
Exactly. But if you download that software, what I'm trying to tell you is that that software, there's a name for it. We call it a Trojan horse. You think that this software is actually running in the background and making your internet faster, but actually it's not doing that. It's spying on you. It's getting information from you, and so on.
Even if you use VPN, sir?
Yes, even if you use VPN. If you have a Trojan horse on your computer, usually we can detect when our computer becomes slower. We know that there's a program going in the background. So you can go to your, you can go and check what are the applications and processes you are running. Okay? And then perhaps you can find out why this particular application is using 40 or 50% of my processing power and 70% of my memory. What's going on? Okay. Then what you do is go online and go to Google and ask questions. And then other people who are in forums, they will discuss that, hey, this is actually a spyware. Do not install this software. Get it?
Mm-hmm.
But
sir, the task forces, sorry, go on.
Yes. Carry on.
Hey, I'm sorry. So these task forces, are these like employed by specific countries? Like, are they like in every other country, or do they have like a special place where they control everything from?
Yes, they have a presence in all countries, but most of them are US based.
Okay.
Yeah. Going back to the earlier question that was asked, the whole idea of controlling the internet is something that actually you cannot control. As far as the only thing a country can control is their own geographical region and the people's access. Okay. Earlier question about Maxis. If Maxis wants to do something like that, they can, as long as you download that software. But of course, a company, a reputable company like Maxis would not do something like that because that would be against their policy. Okay. It would be perhaps, if you do that, then you lose your customers, correct? So they have to be careful. Okay.
Or they are doing it right now, but they're just too good in hiding it. Do you think so, sir?
Yeah, perhaps. But then what you download and how much you download, these information ISP can know. Because when you access anything on the internet, you access through them. Which websites you have visited? What have you downloaded? What have you watched? Everything, they have this access. The data, the servers that they have. So your ISP actually has got information on you. But when it comes to accessing your actual computer, they cannot come in directly to your computer and play around with it unless they have a software on your computer that can do that. That is why when it comes to your email, do not just download any file, especially an exe file. Okay? Because it can be harmful. Okay, let's move on. So usually a company, an enterprise, an institution has got its own LAN and intranet, and sometimes it shares it with people who are part of, people who work closely with the institution. That would be the extranet. Okay, for example, our connectivity that we have to Perth, because we are that's our mother campus, and we are a branch campus, and the whole wide world, which is our internet. Now, before we go to the next topic, I would like to ask you all. You all are connected to the internet right now, correct?
Yes.
Yes.
Yeah.
Yes.
Wirelessly.
Yes.
Very
Can.
Look at your internet devices. What device enables you to connect to internet? Can you tell me?
My router.
It's 4G.
So you are connected to a router, correct? There would be, perhaps, if I'm not mistaken, a router where you can cable it, or you can use it wirelessly, correct?
Yeah.
Yes.
Yes.
And that router, if I'm not mistaken, is connected to a sort of a modem, correct?
Yeah.
Yes.
Yeah.
No, for me, no.
What are you using? Are you using Unify or Streamix?
Me?
Yeah.
No, I'm not in Miri.
Yeah, but what are you using?
Actually, I'm getting a direct wire from the ISP provider.
Oh,
We're
very
just
good.
using an Ethernet cable.
He's using dial-up
Yeah.
connection.
No, it's not dial-up, man.
So he's lying. We cannot be doing that. So the whole concept is that when you look at our connection, just now when I asked this question, all of us got different replies, correct?
Yes.
Those of us who are in the same geographical location like Miri, or for example, in Malaysia, perhaps will have somewhat similar. But then the moment you have different other connections in different countries, you can see that, hey, no matter what technology you're still connected to the internet. Another thing you will realize that we don't need to have the same technology to connect to the internet. There is always different ways to do it, correct?
Yeah.
Yes.
Okay. Now, let's continue with internet connections, okay? So these are some of the connections that we have. Okay? We can have broadband digital, broadband cable. We can have true wireless connection. So there are many technologies. That's what I was trying to tell you earlier. The different technologies that we use to connect. Okay. Question. I mean, most of you are young, and perhaps you weren't born during the early years. I mean, maybe you were. Have any of you used the dial-up modem of the early internet years?
Yes.
Yes.
Basically, you can't talk on the telephone.
Exactly. Remember how slow it was?
Yeah. And the classic theme song when you try to connect.
Yeah, exactly. Now imagine where we are from those days. Back in those days, and we have advanced a lot, correct?
Yes.
Yes.
That's right.
And when you were in campus in our lab, or when you went to your lecturer's office, did you look at the phones that we use?
Or the Cisco phones?
Yeah, but what is special about those phones?
The IP phones.
IP phones?
Exactly, very good. They are IP phones. We don't use those analog old devices except in the tutorial classrooms. Have you seen the tutorial classroom?
Yeah. On the side.
So the whole concept is that technology is changing so fast, okay, and taking us to new places. So these are some of the connections that we have, okay, and based on these, we have got different service providers, okay. Even in Malaysia, perhaps we can say that we have got different service providers whose main objective at the end of the day is us accessing the internet. And the whole idea of making it a viable option for people to work from home, and especially in this time of the pandemic that we are going through, the whole world can exist and work. Now imagine this pandemic had struck us in 1980. Could we have survived? Could we have worked from home? Obviously not, right? We can work from home right now because we have this amazing technology. Corporate businesses, they require a better bandwidth, a better access. Okay? Sometimes some institutions need direct access. For example, Curtin has a dedicated, perhaps, leased line directly to the internet, and they pay some amount monthly for that, because perhaps their internet usage consists of a higher capacity. If you're using it at home, we may not need. Governments, institutions like banks, they need access through satellite. Why? Because every day they have to replicate the banking database from one location to another location. Otherwise, all the banking information cannot be just stored in one location. What happens if that hardware fails or somebody attacks it? It has to quickly be replicated. The moment you put your ATM card, withdraw the money, that information has to go to the KL server and immediately replicated to Singapore, to New York, to Sao Paulo. I'm just giving you an example, okay? And for this to happen, you need a fast network. Have you noticed sometimes you go to offices and they are not working? They are not doing anything, and you ask them why, what's going on? They say, no network, cannot access the server. Have you noticed that? So when there is no network, what happens is they cannot work. They have to wait. And along with them, the customers in that office, be it post office or be it a bank, all of them have to wait, correct?
Right.
So that is why we are dependent on this technology. Okay? Have you heard the concept of dirty bomb? Have you heard that?
No.
Yep.
No.
Anyone?
Isn't that
Yes. Carry on. Yes.
isn't that another name for a nuclear bomb? Something that when it explodes, it has a really huge fallout.
No, a nuclear bomb. A nuclear bomb actually releases too much energy that destroys physically a certain area. But there is something else that happens before the nuclear weapon explodes, and that is there is an EMP, electromagnetic pulse, that is spread in a certain, depends on the strength of the device, that is spread.
To mess up wireless connections and stuff.
No, it's a very strong pulse that fries your electronics. So
An EMP.
yeah, that happens in a nuclear attack. But now what you do, you can create a device that doesn't destroy the geographical place physically, like what the nuclear weapon does, but it just destroys the geographic locations, electronics. Just imagine you are driving your car and suddenly it stops. No matter how much you start, it doesn't start. Or you are at home surfing the net and then your computer stops working. Your power goes off. Your air conditioning stops working. You come out and you see it's the same every place. What has just happened, perhaps, is somebody has activated a dirty bomb. Or what has happened is maybe we
So
should
everything
say a
just
dirty
gets
bomb.
disabled and like not destroyed or something.
Yes, yes,
But the data is still there.
yes. Perhaps a better name would be somebody has activated an electromagnetic pulse bomb that can destroy a certain areas circuits. All the electrical circuits will be fried. And we don't have any normal device, that doesn't have some electronics circuits inside it, no IC. So we would be, we would be back to Stone Age. Okay. A dirty bomb can also be an example of a bomb which releases radiation. Okay. The thing about a nuclear weapon is it destroys people physically. It also releases electric magnetic pulse, and it also releases radiation. So it's the worst of the worst. But you can separate these three components. Okay?
Sir?
What I'm saying is, in this day and age, you can have actual device that can fry the electric components of a certain geographical location. And the moment that happens, that means they cannot communicate with each other. And you have actually heard that plays tremendously. Okay. Now, another concept you should know in this day and age, this is the age of streaming. This is the age of Netflix, of Amazon Prime. This is the age where we have got convergence of network, whereby our data, our talking telephone, and our video broadcast, everything is converged into one medium. Most of us, if we look at our telephone, for example, when I look at my home connection, my phone is connected to through different wires, it's connected to the fiber optic cable. I have got a TV box which is connected to the fiber optic cable. My modem, which takes my digital connection and changes into optical pulses, okay, is connected to the optical cable. My digital connection. So this optical cable is supporting so many things just in my home. Okay. All the computers. And if you look at the size of this optical cable, it's pretty small. So this is the advancement of technology that we're using these days. And the entertainment, the data, the communication, all of that goes through that single optical cable, the convergence of networks. Okay. In this day and age, most of us use IP telephones, okay, because that would be a better option compared to our old analog devices. So a converged network ensures that data, voice, video, everything is carried through one medium. Okay. A few years ago, there was discussion about this, whereby everybody, they were discussing about payments for accessing the internet. There was discussion about streaming companies. They should pay more because their data is taking most of the bandwidth of the internet. So that was one of the discussions. Now, in order to make sure that your convergence of network is successful, you have to make sure that you have a proper quality of service. Now, all these things that we have discussed, you can actually, in your lab session, simulate your network by creating it on Packet Tracer. I believe all of you have downloaded and installed Packet Tracer, haven't you?
Yep. Yes.
Okay. Great.
Yeah, it's already done.
Okay.
Yes.
Yes.
What I'm going to do, I'm going to simulate packet tracer. Let me open packet tracer on my computer to share it. Can you see my packet tracer? My dear students, can you see it?
Yes.
Yes.
Yes, sir.
Okay, now let's start with something basic. Okay, let's create a connection between two computers. There, two end devices, a generic computer connected to another generic computer. Okay. Now we go to the cabling. We create a connection which is, let's say, a straight through copper cable connected to the NIC, which is called fast Ethernet 0, to NIC of the second computer called fast Ethernet 0. Now, this is the first lesson you learn immediately, that you cannot connect two computers with a straight through cable. You always have to use a
Crossover.
Yes, very good. So what I do is I delete this, press the delete button, and delete. And let's do it again. Okay. Go to a crossover cable. Again, connect with fast Ethernet 0 of the first computer to the fast Ethernet 0 of the second computer. Immediately, you see you have a physical connection. Can you see that? But you don't have a logical connection. You have not given IP address, so you cannot ping. Now, for that, what I'm going to do is I'm going to just come over here. Can you see what I'm doing, all of you?
Yes.
Yep.
I go to my desktop. I go to the IP address. But before that, I want to give a name to my computer. The first computer, I give the name PCA. There, PCA. And my second computer, I'll give a name PCB. Okay? That's it. PCA and PCB. Now what I'm going to do is I'm going to give an IP address. I go to the desktop applications, I go to IP configuration, and I give an IP address 192.168.1.1. Okay? Subnet mask comes automatically as 255.255.255.0. So all the computers in this network will have the same subnet mask. Okay, remember I told you, when you want to connect to the same network, you use a switch. This is the meaning of the same network, having the same subnet mask. Okay. So, if this is my first IP address, this is IP version 4, 192.168.1.1, consisting of 4 quarters. Okay. 192.168.1.1. So this is my PCA address. So my PCB will be 192.168.1.2. Get the idea? Yes. So we will talk more about IP addressing, and as you go along the course, you'll be experts in it. Okay? No worries. Now we go to PCB. We go to the desktop. We do the same thing. This time I say 192.168.1. If I type .1, what will happen? There will be a clash, correct? So I type 2. And then subnet mask should be 255. It comes in automatically because the moment you type this address, Packet tracer knows that you're typing type C network address, so it comes out automatically. Okay. For this kind of IP address, this would be the subnet mask. What does this mean? This means that an IP address, first of all, has got 32 bits. Each octet has got 8 bits. Okay, 8 bits. So when you have 255, 255, 2550, okay, that means 8 plus 8 plus 8 is the network portion of the address. And 8 is the host portion of the address. This is just for your information. We'll be covering this in detail. Okay, we don't need to worry about this right now. So when you give the IP address for PCB, now there we have it. Now let's see whether we can ping from here to here. We go here, we go to the command prompt. Can you see the command prompt, my dear students?
Yes, sir.
Yes.
Now what I do is, the first thing I type is my IP config. Yeah, it tells me my IP address is 192.168.1.1. Can you see that?
Yes.
Next,
Yes.
what I do is I do a ping 192.168.1.1. Can I ping myself? Yes. You can ping yourself to make sure that your TCP/IP is working. Okay, there, it's working. When you get a reply, that means it works. Now let's ping PCB. For PCB, the IP address was 2, correct?
Yes. Yes, it was.
There we go. You see, you get a reply. Okay, packet sent 4, received 4. So the connection is successful. Okay.
So what would happen if you have the same, like if you put the same IP address on both computers? Like what if somebody spoofs the IP and it turns out the same in the network?
For packet tracer, it will immediately tell you that you're making a mistake. Okay.
Okay.
You won't be able to communicate. Okay. The logical address should be different. Now, the other thing that you said, spoofing. Spoofing is usually done on the hardware address.
The MAC.
Yes, the MAC. But most of the, for example, many years ago, you could spoof your WhatsApp. But now WhatsApp has got certain, when they upgraded it, it has got certain protection that it's really very difficult to do it. Okay. So what we do here is, what I do next is try to ping an IP address that does not exist. 192.168.1.3. It's trying to find a computer on the network. But we know that the computer doesn't exist, right? So you see what it says? Request timed out. Okay. It is trying to send the second packet, it cannot find it. It sends the third packet, it cannot find it. It will send the fourth packet and then stop. Say, hey, I looked and I couldn't find it. Okay. Packet sent, 4. Receipt, 0. Okay. So you have to know the concept of the ping command to establish a network connectivity. Now, let's go to our PCB and do the same thing. Open your command prompt. First of all, what was my IP address here? It was 192.168.1.2. So ping itself 192.168.1.2. There, I can ping myself. That means my TCP/IP is working very well. Now I ping my PCA, and I can ping successfully. No problem. Now what I do is, let's take it up a notch. Instead of connecting a PC to PC, let's connect a PC to a switch. You take a normal switch. Okay. and I remove this table. Sorry. Okay. And what I do is, instead of connecting them directly to each other, I connect PCA to a switch. Now this is my switch. Look at my switch has got 24 ports. Can you see? 24 ports. So I will connect PCA to perhaps fast Ethernet 1 and PCB to fast Ethernet 2. Okay. Using this time straight through. No need for crossover. So here we go. Connect to fast Ethernet. And another one connect from fast Ethernet 2 to my fast. That.
So why are we not using the same cables?
Very good question. The reason I've used different cables is I want to tell you that, hey, even if you use same cables or different cables, the switch can still make them connect, because the switch it has got software smart enough that it can make sure it will connect both of them, even if you're straight through. Can you see what I'm trying to tell you?
Yeah, but would it affect the speed of the connection?
No, it won't. It won't.
Oh, okay. Right, thank you.
Doesn't matter if you use a straight through or a crossover, it will still connect. But usually, now let's do it correctly. Usually, from a PC to a switch, we use it straight. Okay. Now, immediately when you connect, it shows these amber lights. Okay. And then after some time, the amber will become green. This one is actually replicating your actual devices. In your actual devices, hardware devices, a switch and a router, they behave exactly in the same way. Okay. Now, if it is amber forever and does not change to green, then we'll have a problem. Okay. But at some point, it changes. Now, you don't need to give an IP address over. If you want to give an IP address over here, you have to give an IP address for every port. Can you see this? Or you can create a VLAN, a virtual LAN, and that virtual LAN can encompass the whole device. Now, we won't need to create a virtual LAN over here right now. We can straight away go and ping from PCA to PCB. That was the IP address, correct? For PCB? Now let's see. Yes, it can still communicate through the switch. Can you see that?
Mr. Foad, your command line is not clear.
My voice is not clear?
No, the command prompt. It's not visible.
Okay. How about now? Is it visible now?
Yeah.
But it's at the bottom, right?
Okay now. Okay now.
Okay, fine. So, I do it again. There you see, through the switch, you can communicate. Now, what we do, we go and from PCB, we run the command prompt again, and ping, say it says over here, PCB, ping 192.168.1.1. That was your PCB. And we can communicate. Successfully, all the 4 packets are returned. Okay. So through the switch, you can connect multiple computers. So I can connect all the 24 computers to this switch. Okay. We even have ports, if you see, we even have ports, gigabit Ethernet ports, that you can connect from one switch to another switch. Okay. And you can make it as complicated as you want. No, actually, you can, for example, connect, let's do a physical connection rather than a geographic connection. You see, what I do is I take another generic computer, connect them to a switch. Here it is. I connect them to same cable. Let's say connect to 24. Connect to the 23rd. Okay. Now, for example, this one can be in Miri. This can be in Perth. Okay. Now, I'm going to connect them, perhaps, I don't know, through a cloud. Okay. Perhaps, yeah. Let's try to connect it through one cloud and another cloud. Okay. Do some room. So perhaps I can connect it with a serial cable. I connect the clouds with a serial 0 to serial 0. Okay, that green. Now I will use a straight through for the switch with the cloud connection. Okay, and same thing. I'll use a straight through for the switch to the cloud connection. There. Now this network, at least physically, can connect to this network. But all we have to do is give a logical address for our clouds. Logical address for this connection, this connection, this connection, and this connection. Get it, my dear students? But the fact that everything over here, you see, the moment, why is this still amber? This has to change it there. The fact that you get this blinking green lights, that means, hey, your physical network is working. Get the idea, my dear students?
Sir, I'm so sorry, but can you repeat this?
Yeah, I repeat, the fact that you see this blinking green lights means the physical network is already up and running. Get it? But you can still not ping from here to here until you establish the logical and IP addresses for the clouds. Get it? So you have to give IP address for this, for this, for this, for this, and so on. Okay? In fact, it won't be so straightforward. You have to perhaps put a router between them as well. So you can create a complex network within minutes on a packet tracer. Okay? You'll be doing something like that as we go through the course. No worries. Now, I'm going to stop sharing and go back to my slides. Okay. Okay. The concept of reliable networks is next. Okay. What is a reliable network? A network that is fault tolerant, which has got a good quality of service. That means when you get your data, when you see your video, the quality should be the same as the source A network should be scalable. That means it should be able to grow. Okay, think about Curtin. When Curtin was set up in the early years, the capacity for the network was small, but look at it now. It keeps growing year by year. And the most important thing, a network should be secure. So let me look at some of these aspects. For example, fault tolerance. Look over here, the router has got multiple connections. Why? Because if one router fails, no problem. The other one can take over. Okay? Redundant connections is always good. Scalable, you can keep adding new nodes to it. Our engineering building did not exist before. It just came up perhaps in 2017. I mean, when it was occupied. The moment we had a new building, that means you have to have new devices. You need to have switches, you need to have computers and devices, intermediate devices, correct? So a network has to be scalable, because any institution that you're working in grows. When you're studying all these things, my dear students, remember that you are learning these things so that you become a network professional. You would be actually creating networks. Okay, that's why you're studying this. The quality of service is very important. Like I said, data from the source and data coming to you, okay, the receiver, there shouldn't be demise in the quality. Okay? And you should know that priority should be given to which one. For example, voice will get a more higher priority than actual data. Okay? Because for voice, we need to maintain a smooth, uninterrupted experience. Okay? And the fourth component, security. You should make sure that there is a proper authorization. Every person has a valid account. You should have firewalls. You should have a proper administrator access. Security is also logical as well as physical. Like I said, where is the room where you put the routers and the aggregate switches? Nobody should have access to that room except the network administrator, because you can actually do a lot of harm. Just imagine this is Curtin and there is an exam season going on and somebody has access to the network room, physical access, and you just go in and bash the network into every devices. That's it. Students have no access to the internet. They cannot submit their assignments. They cannot access it. They go to the library, no internet. You can do massive damage. Okay? That is why it's very important. Security, both physically and logically. And that a network administrator can maybe access the network and make changes to his router from his home. Even at home, he has to make sure that nobody else has access to his end device, because they can do a lot of damage. As you go through this course, you will learn internetworking operating system commands. And as you learn these commands, you will know that, hey, I can pretty much do whatever I want. That's why I told you earlier, the network administrator in any institution is the most powerful person. Okay? We'll look at some of the network trends. Before we go to network trends, anyone can tell me, how do we enforce security to make sure that our data is secure individually? Anyone?
Having strong passwords and off-site backups.
Very good. Anything else?
Two-factor authentication.
Yes, very good. Anything else? Very good.
Different security layers such as firewall and all of this stuff.
Yes, very good. What about encryption? Have you heard about encryption?
Yes.
Yes, encrypting your data. Whenever you get an email message with a suspect link, don't open it. Never open it. Only open it by using your friend's computer. I'm just kidding. Just kidding.
Okay. I'll be using Sam's computer.
I'm just.
So I have a question.
Yes.
Like, if you're working with different networks, like a bunch of different networks which are like only IPv4 or IPv6 bound,
Yes. Yes.
do you face any limitations, like when trying to connect them or work with them?
No, that's the standard. When we have a connection between computers, either it's IP version 4 or IP version 6 or both. Okay?
Okay.
If you don't have that address, your computer, your device rather, is not part of the network. Okay?
Okay.
Now, there is another thing. We do not give individual IP addresses. Because just imagine in an institution where you have got thousands of devices. Imagine Curtin. Do you think the network administrator is sitting there and giving IP addresses individually to all the devices that are logging the network? Not possible. It will go crazy. What happens?
So for different devices, it's MAC address, which is different, right?
Yes, the MAC address is different. In the same network, the IP address is different as well. Okay? I mean, it has to start like I gave you an example: 1, 2, 3, and so on. The host portion, the network portion will be the same. The host portion will be different. Don't worry about your IP addressing so much. We will cross that bridge when we come to it. And every week when we study, you will learn more about it. For now, remember, if you want to connect computers to each other, they need to have a network address. I'm talking about the logical address. And that network address needs to be IP version 4 address, which we used just now when I did my packet tracer, or IP version 6.
What if you have an IP version 4 but trying to connect to a network which is only bound to like 6?
Yes, can. That's the whole point.
If you can still connect?
Yes, can. We have a translation medium that translates from 4 to 6. You're going to study all this, It's part of your course.
Okay.
Yeah, no worries. So, actually, that's what I'm saying. This course is very interesting because of the lab component. Okay. Some of the recent trends that we have is bring your own device. I remember many years ago, at Curtin, they were discussing, at our campus, they were discussing that, hey, let's not have any more computer labs. Let's close all our computer labs. Whenever a student registers at Curtin, we give them a computer. Here, this is your computer. That's it. They take the computer wherever they want, and they can access. There's no point of having any more computer labs. And then we discussed, and we discussed that it wasn't a good idea, especially for computing students. They need access to a dedicated lab where they can experiment and do their own stuff.
What if they just join and then withdraw and leave? They have the free laptops to themselves.
Yes. That all those questions were asked and
answered.
And decided to do it. Yeah, but then the management will not be silly to just give you a laptop without asking you to pay some security.
Yeah, that's true.
Anyway, we decided that we will, for now, we still have our computer labs because not all students can install all the all the necessary software. And some software that you use, you have to pay licensing fees. Okay? So it will be easier to have those licensing fees in a particular location rather than all the computers, right? Like MATLAB and all that, the licensing fees is you have to pay for those licensing fees. So it's
it's a lot.
Yes, it's substantial. Yes. Online collaboration, video communication, cloud computing. We haven't realized the whole potential of working online until this pandemic struck us. Have you realized that, my dear students? In fact, ever since this pandemic has struck us, some of us, we find that we are more busy than before. At least, I mean, as a lecturer, I have got lesser time than before because I have to be online and do this. I have to give reports about my online activities with my students. Okay?
Yes, our timetables are more filled up now, like a lot more filled up. I have classes from 8 to 6 on a daily, which is not fair.
Even as a student, your activity perhaps from the comfort of your home, nevertheless, is the quality perhaps may be better. I'm not so sure. Maybe. So bring your own devices and just connect to the network and use it. Okay. Very soon, the whole concept of having a smartphone and a computer, I'm still waiting for a day when they are all merged together. I don't understand why they don't do it already. I have got a notebook. I just, have a port on my notebook where I can put a SIM card in it. That's it. Why it has to be so complicated? So hopefully some of our engineers will work on this. Okay. Online collaboration, like what we are doing right now, my dear students. Okay. We are in fact using the same technology, right? Cisco Webex, correct? And the whole idea of collaborative learning has been around for so many years. We say, yes, we'll use it. But ever since this pandemic hit us, we learn new terms like Zoom. What is Zoom? Okay. We actually started using Webex, which we had never used before, and so on. Video communication. These are some of the trends that are changing our industry and our way of working. Cloud computing, accessing data centers where data is stored. Okay, that's where cloud computing is made possible. We have got 4 types of cloud computing: public clouds, private clouds, hybrid clouds, and custom clouds. My dear students, as you go through your online NetAcad session, you will be actually studying all these things. Make sure you go through page by page, because the exam that you give will be related to this. Okay? Remember, every chapter has got an exam associated with it. I'm not talking about a quiz that you go through at the end. I'm talking about another exam which has to be activated by your Cisco instructor. Who is your Cisco instructor, my dear students? Yes, I am your Cisco instructor, and based on my grading, at the end you will know whether you have passed or failed your CCNA. Okay? CCNA consists of 3 levels: CCNA-1, CCNA-2, CCNA-3. Right now, we are doing CCNA-1. Okay? At the end of this semester, you will get your CCNA-1 certificate. As long as I'm satisfied with your learning. If I'm satisfied with your learning and you have actually proven to me that you know how to create a network, you know your IP addressing, you know how to configure a switch and a router. That's it. I'll give you a certificate with my signature. And you are certified as CCNA-1 professional. Then, when you do distributed networks, you will do CCNA-2 and CCNA-3. And then you will get your CCNA-3 certificates. Okay? Some of the technology trends we have is working from home, which all of us are doing. All of us are working. You as students are also working. What is your work? Your work is to understand the concepts, to study, and to prove to your lecturer that, hey, I am proficient, and the proof of that proficiency is the marks that we give you. So as a student, you're also working hard. In fact, you're doing the hardest work. You are using your brain to think. Okay. Of course, sometimes we take shortcuts. We plagiarize and all that, and that is bad. That means we're not doing our work properly. Okay. So we have to make sure that we don't take shortcuts. We actually do enjoy the learning process. And in this session, we will be actually doing that. My dear students, have you heard about sending internet signals through your electrical wires? Have you heard about it before?
No.
Yeah, it's called power networking. What happens is your power that comes from the wires, you can also send electrical signals through it. It's amazing. And you don't need to regenerate the signal because the power will regenerate it. All you have to do is have a special adapter to convert the electrical signals into your digital signal. Okay. I remember I have used this technology. I remember I was staying in a hotel in Shah Alam, and they had this technology. So when you go in, they didn't have Wi-Fi in those days. They will give you this adapter. They'll say, here, the internet is here, connect, and then connect it to your computer. And
is it similar to Wi-Fi extender?
No. It has nothing to do with Wi-Fi.
What is it doing?
It's an adapter you connect to your power line, and then with a utility cable you connect to your PC, and then that's it. You're on the internet. Amazing technology.
Oh, so you don't need a different connection. You just need this box.
Yes. You don't need any other connection. They have one adapter that will be connected to a Wi-Fi router as well. They have that, but then the thing is, it's not as fast as your optical cables, the technology that we use right now. Okay? Fiber optic cables are much more faster. But anyway, this was an amazing technology, and we still have it. We have got wireless broadband service. Our cellular networks mostly work with that. We also have in remote areas where wiring is not possible, we have got service providers who give wireless service, called wireless internet service providers, and so on. Now, this is another important aspect of network connectivity. Okay. When you are in a network, always expect a threat. Okay? That's why we have got firewalls. Firewalls can be physical as well as software-based. Network security is a serious business. And like I told you earlier, every country has got another different department related with cybersecurity. Okay? External threats can be in the form of viruses, worms, and Trojan horses. Anyone knows the difference between a virus and a worm?
Virus goes and reproduces at a stream rate.
And worm? What happened? Anyone else? Anyone? A virus and worm are pretty much similar, except that the virus needs to be copied from one location to another. A worm can create a copy of itself and spread by itself.
Oh, so it self-replicates.
Yes, yes, very good.
Alright.
A Trojan horse is a program which says it does something, but actually it does something else. It's a harmful program. Like I gave you an example. You download a software. It says that this software is for downloading music files. Okay, but actually it does download music files for you. But in the background, it can do other things like collect information from your computer, record your keyboard strokes, or perhaps see which websites you're visiting, and get information. So these can be called Trojan horses. We have spyware, adware. We have got zero-day attacks. Okay, an attack by a worm or a Trojan horse that doesn't have a cure yet. Okay, there's so many documentaries on this zero-day, interesting documentaries. Okay. We have got individuals who attack certain institutions. A threat actor, we call them. We have got denial of service attacks. What you do is keep sending multiple requests to a web server that it gets overwhelmed, and it cannot process all the requests. So you get a DOS attack over that. You can have data interpretation and theft. We can have identity theft. Find out who is on Facebook, copy their picture, and copy their identity and have a duplicate identity and use that to gain some advantage on or gain some information. So you can do pretty much a lot of things these days. And in order to protect yourself and your institution, you have to look at security. You can have also internal threats, stolen devices, misuse of your resources by employees, accidental or intentional. You can have malicious employees who are upset with the company and can harm it. Okay. So you have to come out with a viable security solution, a blueprint, and not share that blueprint with anyone. You shouldn't tell where is your network security, where is your network intermediary devices room? Which place in the building is your actual outgoing router? Okay? Because once you get that, no more access to the internet. You should have firewalls, you should have antivirus. So you should plan your network very well. You should have access control lists, something you're going to learn in CCNA-2. You should have intrusion prevention systems. You should have virtual private networks, VPNs. Your other computer can be in Australia, but it's part of your own network. Now, as IT professionals, we have a series of certifications. For example, after finishing your CCNA, once you get a 3 certificates, you can go for a CCNA certification. And that is industry standard. Enables you to get jobs easily. Okay? You can look at some of the job opportunities. All right. Now that we have come to the end of the session, what I want to do is, can you please access your Moodle? Access Moodle and open your lab exercise for today. Access your Moodle, please.
Sir, is it the network representation one?
Yes.
Okay.
Network representation, please open it. Can you see it on my screen?
Yep.
Very good. Okay, let's try and solve this together. Identify the common components of a network as represented in packet tracer. Anyone can answer this? Anyone?
A router to switch.
Yes. Anything else?
Wires.
Yes. Yes. Media. We call it media. What else?
The host, the computer.
Yes, very good. The host, the computer, and so on, the cloud, and so on. Okay.
Data center.
Yes. Without entering into the internet cloud or intranet cloud, how many icons in the topology represent endpoint devices? Can anyone give me a number? On packet tracer. Perhaps you can count and come out with a number. The next one, without counting the two clouds, how many icons in the topology represent intermediary devices? That is multiple connections leading to them. Again, you can count and put a number there. How many end devices are not desktop computers? How many different types of media connections are used in this network topology? In the example I gave you, how many network devices did I use? Connections? I use straight through, I use crossover, and I also use a serial connection, if you observe, when I use the cloud. Next. In packet tracer, only the server packet tracer device can act as a server. Desktop or laptop PCs cannot act as a server. Based on your study so far, explain the client-server model. Anyone can tell me the client-server model? Anyone would like to say something about it?
Can I get?
There's a strong echo. Perhaps because you are using two computers. You can mute one of the computers, and then there won't be any echo.
All right. How about now?
Yes, better.
Okay, cool. So as I was saying, the client-server model is based on the fact that instead of computers connecting to each other, they connect to one modem, which acts like a server. You have a server PC that's a dedicated, that's a dedicated platform, and each computer individually connects to that. They don't connect to each other. And over there, in order to access or in order to log into the network, you are given authentication of a sort, like a username password. So once you're authenticated, the server over there, the modem in this case, it'll allow you to connect to other computers onto the network as well. That's how I understand how client-based is.
Yes, very good. And the server, what it does is it generates information as per the client request, correct?
Correct.
Another thing is, as compared to peer-to-peer network, we studied that the client-server network is much more secure than peer-to-peer, correct?
That is correct.
Okay. Next, list at least two functions of intermediary devices. First of all, what are intermediary devices? Example?
Firewall.
Firewall. Let's talk about the two devices that are
Routers, switches.
Routers
and switches.
Very good. Once again, a switch is used to connect the same network. When I say network now, today I have taught you something new. I told you IP address has got two parts. One is the network address. What is the host address? Remember?
Yes.
So when I say having the same address, that means the network portion will be the same. So for IP addresses where the network portion is the same, then you can connect to the same switch. Okay? Today, remember I taught you IP address 192.168.1.1. The first three octets, 192.168.1, is the network address. That one you cannot touch. The only thing you can touch is the fourth octet. That can change to 1, to 2, to 3, to 4. Get it? It can go from 1 to 255. Like I said, we'll discuss this. Go. Okay, now let's go to the functions of intermediary devices. What do they do?
Increase security.
Yes, very good. One is that. They also network devices. Otherwise, without enough network. Switch connects the same network. Router connects different network. Without a router, no internet. If you have no router, that's it. You're dead. No internet. Okay. And another important property is they regenerate the signal.
So one thing, we can also we cannot have an internet without a switch also, right?
Cannot. If you're accessing your local switch, can you stop that? If you do not have a switch, you cannot connect the local area network. Okay. We used to have a device before the switch. It was known as a hub. It was much more slower than a switch, and it never regenerated the signal. That's why it didn't, actually the first hubs, they didn't need even a power supply. They were just connection devices. But now hubs have been phased away and we use a switch. Despite the fact that you have an icon on packet tracer for hub, but we don't use that. Even in the lab, we don't have a hub. Okay, because it's a device that belongs to Jurassic Age. Next, list at least 2 criteria for choosing a network media type. What are the 2 criteria? Anyone? Okay, I'll give it to you. You can write it down. The first one is the distance that it has to travel. Okay. The second one is the amount of data, the bandwidth that it can carry. The third one can be the environment, which place or kind of place. Okay. Next, compare and contrast LANs and WANs. Okay. Explain the difference between a LAN and a WAN. Give examples of these. So this one, please look in your NetAcad and try to answer it. In the packet tracer network, how many WANs do we see? Okay. We see 2, the internet and the intranet WANs. Okay. How many LANs do you see? That depends. Based on the topology, it can change. Okay. Next, the internet in this packet tracer network. I think there is a packet tracer. Question number D, briefly describe the internet. Internet is a connection of networks. Next, what are some of the common ways a home user connects to the internet? Anyone can answer this?
Wirelessly through a cable.
Yes, and wireless, cable, DSL, dial-up, cellular, and satellite. Next, what are some of the common methods that business use to connect to the internet in your area? Businesses normally need a higher bandwidth, so they can use dedicated leased line to the ISP. Can be DSL, can be cable, can be satellite, can be fiber optic. Now the challenge question that we have over there, I think we did this while I was doing for you the packet tracer. Now what you need to do for this lab, you don't have to show me anything, just this is for your own revision. But starting from, stop sharing. Okay, my dear students, if I have your attention. But starting from next lab, you all have to do a scenario, a topology on packet tracer and show me immediately after you're done. Okay. What you will be doing is you will be using Webex, and you will share your screen and show me your packet tracer file. If I ask you to do a ping, and if I'm satisfied with everything, you are done. Otherwise, I will ask you to do it all over. Okay, remember every lab exercise is an actual exam. Like today, also what we did here is an example, and this one we don't need to individually ask you because the answers are very short and you can get it all in your lecture. That brings us to the end of the first session. I hope it was enlightening and not too much information. Anyone has a question that they would like to ask?
Sir?
Yes?
So we don't have to submit anything, right? We just have to show you during the lab.
Yes. For the first lab, usually we ask you to submit this, answer it and submit this. But no need to do that because we discussed it. And all the answers are actually not activity-based. The activity-based will be starting from lab number 2 next week.
Okay, thank you, sir.
And remember, in the first week, we are not supposed to do any lab, but I started with this week so that we are, we are one step ahead, and that gives us room to practice and practice and practice more. All right?
So what would you say is the most challenging aspect of this unit?
IP version 4 addressing.
Okay. Not the fact that you have to memorize so many things.
No, listen. Memorizing is not an issue because when you do packet tracer, when you do it multiple, the first time you do it, you notice how I how I use packet tracer? You won't be able to use it right now like that until at some point you become comfortable with it. The commands, I have used it so many times, it's in my brain. Even sometimes my colleagues say, how can you remember all these things?
No, not that. I mean, the theory.
Oh, the theory. I'm afraid, yeah, you have to, especially for your final exam, you have to remember. But for the skill-based exam, right now we are talking about CCNA. For the CCNA, also you have to remember the commands that how do you give an IP address to a router? You should know the command. How do you get permissions on your router and your switch? How do you create a VLAN on your switch? How do you give an IP address to your VLAN? All this.
When you do ask that question, you have to start from the enable part or just give the command list. So
very good question. No, you have to start from enable.
Okay, square one.
Yes. So that enable, those things you'll be learning next week. Okay. Now, my dear students, I will be very lenient with you all. As far as the exams are concerned, you can, the chapter exams and all. But when it comes to the actual lab exercise and skill base, I will not be lenient. You have to show the exercise to me and you have to explain it to me. If computer A cannot ping to computer B because of your setting, I will not accept it. I will not fail you for that lab. I will tell you, do it again and show me later. Okay?
Okay.
Your skill for the lab should be perfect. Okay? Otherwise, that means you don't deserve to get that degree.
Fair enough.
Certificate. Yes? Somebody had a question? Anyone has any question?
I think in the chat they have questions, sir.
Okay. Does that mean we have lab tests every week, which carries 40% of internals? No. The lab test every week that you have, it's not every week. It is based on certain chapters, like chapter 1, which we did today. Chapter 2, chapter 3, chapter 4 will have one lab test. Okay? I will tell you when I will release that lab test. All the lab tests will have 10% of your CCNA. Okay? And then there will be a final exam for your CCNA, which is 20%, and your skill-based exam, which you do it in front of me on on Webex like this, that also will be 20%. So 20, 10, 50% is your CCNA. And until today, I have taught this unit for the past, I think 6 or 7 years. Until today, nobody has failed my CCNA. Until today, everybody has passed. Okay, but they have done their job. They have done their job, and they deserve to pass. So maybe this year we will have somebody. We will break that record. We don't know.
So I'm not quite understanding the program calendar. Like it says assessment information, but then it says last chance to take this thing. Like when is the first chance?
Which section of the program calendar?
Like the whole thing, the whole program calendar itself.
Okay, listen. The program calendar that you see over there are 2 sections. One is the actual lecture.
Yeah, the tutorial.
Yeah, the tutorial is connected to the lab as well as the lecture. Okay.
Okay, and the net is the seminar.
50%, which is final exam at the end of the semester. The other section, the lab, that is CCNA. That has nothing to do with Bentley. That is only under your instructor. Who created your NetAcad ID?
You.
Yes, that means I can give you your certificate as long as you prove to me that you are good in doing your lab exercises and doing your skill base. Get it? So if you are late 1 week and say, hey, I'm sorry I didn't do this lab because I had some problem and I couldn't attend, but I will show you by next week. So if you give me that notice, no worries, I will accept. Okay? That has nothing to do with that is between you and me. Get it?
So I have a question. So do we have to do the challenge question in the network representation?
Yeah, you can do it, but for your own practice, not to show me.
Oh, I see. All right. So this lab we have nothing to do, right?
No. You just keep it for your revision.
All right.
This lab actually is more of a introduction session. Okay.
All right. Okay. Thank you, sir.
Thanks.
So, sir, we'll be using the same link for the rest of the classes?
Yes, at least for the next 4 sessions.
Okay.
How will you be conducting the labs? Like if one person shows it, then we all can see how it works, right?
Yeah, but it's okay.
You won't be allowed.
It's okay. It's okay.
It's
He'll
okay.
kick you.
It's okay.
Because even if they see, every time a student is showing me their work, what is happening is you are replicating and they are learning. Okay, learning is happening. No worries. I'm going to stop the recording now.